value of this limit here, and what we kind of got to recognize in this, even though it's very tricky, is that this actually is a definition of derivative. It's going to be of this form, and this is the derivative of f at a. It's given by this limit here, and what we're going to have is that this limit here is a particular case of a particular function. So I want to see what I'm going to have here. So basically what's happening in this case is that you have some function, let's say f of x, and if I make it so my function is x to the 1/4, if I wanted to find f prime of 16, right, and I wanted to use this definition, what would I get? I'd get limit as h goes to 0 of f of 16 plus h minus f of 16 over h. And now all I need to find f of 16 plus h. Well, f of x is x to the 1/4, so f of 16 plus h is equal to 16 plus h to the 1/4. And f of 16 is just 16 to the 1/4, which is the 4th root of 16, which is 2. And what we get here is limit as h goes to 0 of 16 plus h to the 1/4 minus f of 16 is just 2 over h. And now we see that f prime of 16, where f of x is x to the 1/4, is exactly equal to this limit. Now, noticing this is tricky, you want to notice that this limit goes towards 0, so maybe it's h going towards 0, so this is typically the definition of the derivative. H is going to be going towards 0. They use h, so maybe h gives it away that it's a definition of derivative problem and you want to use this equation. You could also use L'Hopital's rule probably on this limit, and you don't even need to know that it's the definition of a derivative and get this limit. But I think we want to kind of be able to identify that this actually is a definition of a derivative problem. Now that we know that it's this here is just f prime of 16, I can forget about the limit, and what I can do is just solve for what f prime of 16 is. I have f of x, I can take the derivative and get f prime of x, and I have 1/4 x to the negative 3/4, and then I could find f prime of 16 by plugging in 16 here. 1/4 16 to the negative 3/4, and I'm gonna get this is the same thing as 1 over 4 the 4th root of 16 cubed. What's the 4th root of 16? That's 2. 2 cubed is 8. 8 times 4 is 8. 16, 24, 32. And I have my value. It's 1 over 32. And again, I could have maybe done L'Hopital's rule here and gotten something. Let's see what happens when I do that. So 1/4, just out of curiosity, 1/4. So it's in the intermediate form because I have that the top part is going towards 0 and the bottom part is going towards 0. So then that means that L'Hopital's rule says that I could differentiate the top and differentiate the bottom. So let's see, I got 16 plus h to the negative 3/4 times the derivative inside is just 1 over 1. And the limit as h goes to 0 of this. This is just limit as h goes to 0 of 1/4 16 plus h to the negative 3 over 4th to the negative 3 over 4. And then this is just going to tend towards 0. So it's going to be 1/4 times 16 to the negative 3 over 4ths, which is exactly, after you do the math, 1 over 32 again. And whether you do L'Hopital's rule like I did on this left-hand side, or whether you recognize this as a definition of a derivative, it's up to you.